Welcome to this explainer. Today, we're demystifying the invisible middle manager running your device. We spend hours every single day on our computers, smartphones, and tablets, right? But how often do we actually stop to think about the digital wizardry that makes all this hardware useful? Well, today we're pulling back the curtain on the operating system. Seriously, think about the exact sequence of events that translates your physical action, a click, a swipe, a tap on the keyboard, into a digital reaction. It feels totally instantaneous, doesn't it? But beneath the surface, there is an incredibly complex chain of command firing off in a fraction of a millisecond. How does a piece of silicon even know what a mouse click means? How does physical electricity turn into a beautifully rendered web page? That is the exact magic we're going to unpack. Here is how we'll break it all down. Section 1. Meet your device's manager. Section 2, the 4 key components. Section 3, goals, convenience, and efficiency. Section 4, inside, kernel and shell. And finally, Section 5, user view versus system view. All right, Section 1, meet your device's manager. So, at its core, an operating system, or OS, is the ultimate intermediary. It's a massive, complex collection of system programs standing right between you and the raw hardware. Think of it like a highly skilled simultaneous translator at the United Nations. Without it, you'd be forced to speak directly to the machine in pure binary code, manually manipulating memory registers just to get a single letter to show up on your screen. No thanks. The OS takes your high-level intentions and instantly translates them into millions of microcommands the hardware can actually execute. It establishes this brilliant abstraction layer so you literally never have to worry about exactly which physical memory sector your photo is being saved to. And you interact with these managers constantly. Maybe you're running macOS on your laptop right now, or some flavor of Windows at the office. Or maybe you're familiar with historically massive enterprise systems like Unix, MS-DOS, or OS/2. Now sure, these all boast wildly different visual interfaces and specific engineering philosophies. Some prioritize impenetrable security, others are all about a sleek, intuitive user experience. But beneath the hood, they all share the exact same core responsibility, making cold, unfeeling hardware accessible and useful to us humans. They are all solving the exact same foundational problem of computing. Moving on to Section 2, the 4 key components. To really visualize this, think of a computer system like a skyscraper built in 4 distinct structural layers. Down in the dark basement, you have the foundational computer hardware, the raw computing resources. This is the brute strength of your CPU, the massive storage banks of your memory, and your physical input and output devices. One level up is our middle manager, the operating system. It strictly controls how that basement hardware is utilized and deployed. Moving up again, we install application programs, your web browsers, database systems, video editors, and games, which rely completely on the OS to function. And finally, sitting comfortably in the penthouse at the very top are the users, which can be human beings like you and me, or even other machines querying for data. This hierarchy creates a super important choke point. The operating system sits dead center as the ultimate resource allocator. A user sends a request to an app, the app turns around and petitions the OS, and only the OS is allowed to go down into that basement and direct the physical hardware. It is the central hub keeping the whole ecosystem from collapsing into chaos. It's the only reason 2 different applications don't try to write data to the exact same physical spot on your hard drive at the exact same time. That brings us to Section 3, goals, convenience, and efficiency. What is truly fascinating here is the constant tension the OS lives under. It's basically being pulled into totally opposite directions at all times. On one hand, it must provide deep convenience. Its core mission is to make executing your programs and solving your complex problems as effortless as possible. You just want to drag and drop a file and have it work, right? But at the exact same time, it has to enforce ruthless efficiency. As that central allocator, it's constantly juggling CPU cycles and memory among dozens of demanding background programs just to ensure the system runs optimally and doesn't crash. Balancing this luxurious, uninterrupted user experience with the strict, unforgiving math of machine efficiency, it's honestly the ultimate high-wire act of modern computing. Let's look deeper in Section 4, inside, kernel and shell. If the OS is a corporation, it relies heavily on 2 distinct divisions to get the job done. First up is the kernel. This is the tireless, active core of the system. It is literally the one program running at all times on your computer. Think of it as the engine room. It interacts directly with the physical hardware using highly specialized code like device drivers and deep system files, handling the raw plumbing of memory and processor scheduling.
Above the kernel sits the shell. The shell acts as the front desk command interpreter. It listens to the applications and translates your commands into a language the kernel actually understands. Basically, the shell takes your order at the counter, but the kernel actually goes down into the hardware to cook the meal. Finally, Section 5, User View versus System View.
Operating systems make a lot more sense when you contrast two very distinct perspectives. From the user view, our perspective, the system is designed for us to entirely monopolize its resources. We want maximum performance for our heavy workloads, our intensive video games, our multiple open browser tabs, all with an absolute selfish focus on ease of use. We don't really care how hard the machine is working, we just want results. But from the computer's perspective, the system view, the OS is an incredibly strict control program. It isn't just trying to go fast, its paramount concern is managing execution to prevent errors, stopping improper use of the computer, and carefully policing those input and output devices. You demand speed and total monopolization, but the system demands total control and absolute safety. So after seeing just how hard the system works to manage your every single click, precisely allocate physical resources, translate your commands through the shell to the kernel, and relentlessly prevent you from causing a catastrophic hardware error, it really leaves you wondering who the real boss is. Are you directing the machine, or is the operating system carefully managing you to protect the hardware? It's a pretty fascinating paradigm to think about the next time you boot up your device. Thanks for joining me for this explainer, and keep questioning the tech you use every day.